Okay, let us discuss this problem. So 1.60, easy problem. So this is related to Newton's law. So problem number 1.60. So let me read. First let me make the diagram and then we'll discuss what this question says. So I have a surface here and there is a mass m1. So mass of this object is m1. This mass is attached to another mass that has a mass of m2. Are you getting? And there is a pulley. So this is a pulley, and over this pulley you have a mass m3. I think you are able to see this one. So this mass is m0. So this is the mass m0. Are you getting? Now surface are having friction and the friction coefficient is k. Now let me read the question. If you have drawn the diagram, let us discuss. So this is figure 1.9 in your book. So let us say in an arrangement shown in the figure 1.9, the masses m0, m1 and m2 are equal to the masses of these bodies, and the mass of the pulley or thread are negligible. So pulleys is negligible mass and threads are also negligible mass. Now there is no friction in the pulley. Pulley does not have any friction. Find the acceleration of object m0. So what is the acceleration of m0? Let us say acceleration is a. So we have to find what is the acceleration of m0. Considering the coefficient of friction between the body and surface is k, find out the tension between the bodies also. So you have to find out the tension also in this thread. So what are the things that you have to find? What is the acceleration and what is the tension between the thread that is between m1 and m2? Are you getting? So you have to find what is the tension in the thread that bonds m1 and m2. Now let us say what will be the free body diagram. If you see the free body diagram, and on this object there is a force that is acting. Let me make the free body diagram here itself, m1g, that is acting downward. Now let us say there is a tension also acting on this tension, let us call T1. Now since this thread is massless, pulley is massless, so here also I will have a tension in this direction T1. Now this mass has a tendency to go this side, so this thread will be basically tight. So in this thread there will be tension this side and there is a tension this side. Now this tension and this tension will not be equal because there is a mass in the middle. So this thread and this thread is not same thread. There are two different threads. That's why this thread will have different tension, this thread will have different tension. Let us say in this thread tension is T. So here also I will have T. Now what are the friction forces? Now this mass has a tendency to go this side. So this means on this mass there is a friction force acting in this direction. Are you getting? And now this friction force will be kinetic in nature and it's given by mu times n. For this surface n is m1 into g. So I can write friction force is k times m1g. Similarly, this mass has a tendency to go this side, so there will be a friction force in this direction, and this friction force will be k times, what will be the value? Tell me. Yeah, m2 into z. Now things are very easy. You have to just write down the equation. Since this mass is going to acceleration a and thread remains taut every time, so this will also have acceleration a. This will also have acceleration a. Now there is nothing new. You just write down the equation and solve. So if you write equation for this subject, this mass is m0. So let us put it here m0. So for this mass, if I write equation m0z, I think you have copied this one, minus T1 is equals to m0a. So this is my equation number 1. If I write equation for this mass is going this side, so let us say tension T1 minus T minus Km1g. Are you getting? Minus Km1g is equals to mass into acceleration. Mass is m1 into acceleration is a. So this is equation 3. Now let us write equation for third mass. Tension minus km2z is equals to m2 into a. So this is equation 3. Now we have to solve these three equations. If you simply add these three equations, you will get the acceleration. If you add the three equations, this goes out, this goes out, so you will have m naught z. So you see this goes out, this goes out, so you will have m naught z minus k z m1 plus m2. This side you will have m0 plus m1 plus m2 into a. Are you getting? So from here you can write, if you take g common, so you will have m0 minus k times m1 plus m2. This is equals to m0 plus m1 plus m2 into a. Are you getting? So you will have a is equals to m0 minus k times m1 plus m2 into z, this divided by m0 plus m1 plus m2. So this is the acceleration you will have. Are you getting? So let us copy this one. Now you have to find out the t. So in this equation, if you plug the value of a, you can find t. So from equation 3 you can find t. So let me see how many of you are able to find this one. So let us find t. So I will wait for some time. So you keep finding, and those who want to see the solution, so let us see. T minus km2z is equals to m2 into a. So what is the acceleration? This value, that is a m0 minus k m1 plus m2 into z. So this is the acceleration divided by m0 plus m1 plus m2. Are you getting? So t will be, this goes this side, and let us say multiply by this. This comes this side and plus sign. So let us say multiply all the terms. So you will have m0 m2 minus k times m0 m2 z, k times m1 plus m2 into z. Now this will come this side, so it will have plus sign. So plus k m2 m0 k m0 m2 into z plus k m1 m2 z plus k m2 square into z, and this divided by m0 plus m1 plus m2. Are you getting? So you will get this value. So let us copy this one. And you can solve for tension from here. So you see, so I can write tension is equals, this is basically equation solving, nothing else. So what are the terms that will be cancelled out? K, you have k terms, so k m1 m2 here you will have into z with minus sign, so this term goes out, and here we will have k m2 square, so this term also goes out, so this term goes out. So you will simply have m0 m2z plus k times m0 m2z divided by m0 plus m1 plus m2. You solve yourself, you will get the same thing. So you will have, let us say, 1 plus k m0 m2 z divided by m0 plus m1 plus m2. So this is the tension between the string. If somebody wants, that can also find T1, that is the tension in other string. So you see, this is the tension in the string. So you solve yourself, you will get the same answer if you are solving, or you just follow the steps which we have done. So you see, in this term this is a minus, this is plus, so this term will go out. So you will have simply these two terms. So please copy fast and then we'll discuss the next problem. I think you have copied this one. Okay, let us discuss the next problem.